Welcome back to Growing Patterns. Today we are going to focus on square numbers type of growing patterns. Okay, another name for it is the sum of consecutive odd numbers. Okay, later you will see why we call it consecutive odd numbers question. Okay, square numbers. This is a type of pattern where calculation of the number of units involve square numbers. Okay, by now you should know what square numbers are. Okay, these are square numbers in bold. 1 times 1 equals to 1, 2 times 2 equals to 4, 3 times 3 equals to 9, and so on. So all these, the multiples, are the square numbers. Square numbers are basically just a number divided by a number, and the product is the square numbers. You notice that if I put this in diagram, you will see that they will always form a square. Okay, square the length times length. 5 times 5 equals to 25, and so on. So please do have an idea what square numbers are so that you can spot them very easily when they come out in your exam questions. Okay, so 1, 4, 9, 16, 25, 36, 49, and so on. These are square numbers. So what other square numbers can you think of? Okay, these are also square numbers. So the patterns in the square number questions may not appear as squares. I'll give you an example. These are all square numbers. The sums are all square numbers. 1, 4, 9, 16. Okay, but right now they don't look like a square. But if you rearrange them, for example, this one comes over here, this will be a square. Or these three pieces, if I shift it over here, and then I will form a square here. Can you see? So it may not appear as squares, or it may appear as other patterns. But what do you notice about the numbers in the addition? The numbers. Yes, they are all odd numbers. Okay, they are all odd numbers. And then we call them the consecutive odd number. Consecutive meaning one followed by another. So the consecutive odd numbers are 1, 3, 5, 7, 9, 11, 13, and so on. And then the sum, meaning I add all of them up. If I add the consecutive odd number up, I will get square numbers. So it's very important that you draw a table and then you insert the information so that you can spot the question, spot the pattern. Okay, because if you don't draw the table, sometimes it's very easy to miss this pattern. Okay, this question here is taken from OnSpan 3.2, question 1. Okay, so this question is given, figure number 1, 2, 3, 4, 5, and so on. And then the number of dots for figure 1, there's 1 dot. Figure 2, there are 4 dots. Figure 3, there are 9 dots. So usually what we will do is we see the pattern and then we write it down. For example, from this one to this one plus 3, this one to this one plus 5, this one to this one plus 7. Okay, so we want to extend the table like this so that we can write down the pattern. 1 times 1 equals to 1, 2 times 2 equals to 4, 3 times 3 equals to 9, 4 times 4 equals to 16. Then we can relate the figure number with the multiple. We can relate the figure number with the multiple so that if I ask you what is the pattern, how many dots are there for figure number 13, you can just 13 times 13 equals to 169. So what is the formula? The formula will be if figure n, how many dots would there be? It will be n times n, right? Or n to the power of 2, n squared, n times n here. So this is useful when the question asks you for a very big figure number. For example, how many dots are there for figure number 132? Then you can just substitute n with 132. Instead of writing n, I write 132 times 132, then I get my answer. So which figure has 576 dots? So now the question asks you, not asking for, they don't tell you which figure number, they tell you the number of dots. So you want to work backward from our formula. So n times n equals to 576. So how do we solve this? So n squared or n times n equals to 576. So we use this square root. Okay, square root, you can find this in your calculator. So square root of 576 equals to 24. So what does this mean? Basically, this means 24 times 24 equals to 576. That's what I mean. But if you don't have calculator, you don't know how to use square root, then it will be quite a hassle to find out the answer. So next time, if the question asks you to work backward, give you the number of dots, remember to use the square root function in your calculator. But sometimes the question is not so easy or direct, especially if this come out in paper 2, the long answer question, 4 or 5 marks. So for example here, figure number 1, there are 2 dots. Figure number 2, there are 5 dots. Figure number 3, there are 10 dots. So at first glance, it's not so easy to spot which type of pattern question it is. So it's important, again, we put all the information in a table and then we draw more columns or row to put in what we can see. So for example here, 2 is obviously 1 plus 1. And then 5, you can write down this is 1 plus 1 plus 3. Or you can say 1 plus 4 equals to 5. And then this is 1 plus 9 equals to 10. This is 1 plus 16 equals to 17. This 1 plus 25 equals to 26, and so on. So why we want to do this? The pattern, we always try to get something with a multiple, use multiplication. So in this case, if I can see that this is 1 plus 1 times 1, this 1 here is equals to 1 times 1, right? 4 equals to 2 times 2, 9 equals to 3 times 3, 16 equals to 4 times 4, and so on. Then I can relate the figure number with the multiple in the pattern. Okay, again, this is always what we want to achieve if we want to get our own formula. So we want to associate the figure number with a multiple in a pattern so that we can formulate a formula with n. So what's the formula? See, this one, this remains the same. The 1 plus remains the same. So the things that change is the multiples. So this one will be 1 plus n times n, or 1 plus n squared. So now the question, if the question asks you what is figure number 21, how many dots are there in figure number 21? So instead of writing n, you write down 21. 1 plus 21 times 21, you will get your answer, 442. Or which figure has 1,297 dots? So this is the more difficult questions. So if you don't figure out some type of formula, you will be very difficult to solve this type of question. So you write it out first. 1297 equals to 1 plus n minus n power of 2 or n squared. So I put this over to the other side. So n times n will be equals to 1297 minus 1 equals to 1296. Then I use my your square root. I use my square root here to find what is n. So if you type this in a calculator, you will get 36. So what does this mean? 36 times 36 will be equals to 1296. So n equals to 36, and this 36 meaning is figure number 36 will give me 1297 dots. Okay. If you don't use formula to help you to solve, another way, of course, you can use systematic listing. This will work if you are patient and you are careful. Okay, because you have your calculator, it is very possible. So all you have to do is write down the basic pattern. This one plus 3, plus 5, plus 7. So next one will be plus 9, plus 11, plus 13, and so on. So you have to patiently write down, key in your calculator, and so on. You can see this plus 9, plus 11, plus 13, plus 15, plus 17, plus 19. It is important to write it down, or else if you get lost very easily with your calculator. So be patient, write it down, and then eventually figure number 21 will be 401 plus 41 equals to 442. So if you use this method, you must be patient and must be systematic. Use a table to keep your workings neat so that you can check them for mistakes. Pay attention to keep adding the odd numbers that are 2 more than the previous one. You can see this 5 is 2 more than 3, 7 is 2 more than 5. So and then eventually you will get your answer.